they need to get just the final active ingredient purified, and column chromatography is a great way to do that. So how would we set that up in our organic chemistry lab? Remember that the stationary phase is the silica gel or other material inside the column, and the mobile phase is the solvent that you pour into it. Well, let's take a look at the equipment. Shown here in blue, we have the column. This has a few different parts. It has an opening at the top through which you can pour things in, a stopcock at the bottom, which I've currently shown in the closed position, and also a flask at the bottom to collect whatever it is you're using. But it doesn't have to be a flask. You could use test tubes or really any other piece of glassware you'd like. So how do we begin? First, we need to pack this column full of some kind of filtration material. But we also want to make sure that that stuff doesn't just run through and spill into the flask. So first you want to put a little cotton ball at the very bottom. This is very small, and usually what you end up doing is taking a long stick and just kind of ramming it right up against the stopcock. Next, what I'd put in is a fine layer of sand, and you want to try to get this to be as just horizontal as possible, not tilted or slanted. And I'll explain that later on, but you want to do that with any layer you're adding onto the column. They should all be perpendicular to your column. Next, what you do is add in the silica. The silica will take up most of your column, and you would be using that to fill almost all of it, just pouring it all in till it reaches a line of, say, about here. Lastly, you'd pour your solvent into the column and make sure that the column is kept wet at all times, because if it runs dry and cracks, it can cause running and mixing of bands. So you would have your solvent line, say, at about here, because if your column dries out, it can crack. And what you'll see is that this is actually going through, again, as I said, the whole column. But this looks a little bit messy, so let me just clean that up for a minute. Next, what we'll want to do is load the column with the actual product that we're using. And how do we do that? You can actually drop it in with a pipette because you want to make sure that the layer is very even. So let's draw it out here. On top, you have this fine layer that you're dropping in on top of the silica gel. But how can I push this through the column and into the flask? Well, the first step I'll need to take is actually just opening up your stopcock. So why do we need to open up the stopcock? Well, when you pour in the solvent, you want the band to start going down the column and traveling down, and that'll only happen if, the liquid can flow out the other end. So let's redraw our silica line in here. This is now where your silica is, but as you see, the original green band has separated into two distinct bands now. You can kind of see a yellow one and a blue one. In real life, the colors might not be quite this distinct, but you get the idea. And as this proceeds, again, you'll see the silica line, but the separation between the two bands will actually become more and more distinct. And so far what you've been collecting in your flask is mostly all just solvent. But how do we actually collect whatever's in the blue band? I mean, we might not know exactly what compound it is, but you can tell that by the fact that they're traveling at different rates, the blue and yellow bands probably have different polarities and are different compounds. So when you see that the blue band is getting really close to the bottom, you'll want to quickly switch out your old flask for a new one so that what you've collected in the new flask is just this layer of the blue compound, while in your column you still have the yellow layer. Note that each flask you collect is considered a fraction. And that's how you'd conduct column chromatography. So earlier I was telling you, you want to make sure that these are pretty much horizontal. But what happens if instead, when you're packing your column or pouring something in, it ends up looking kind of crooked? So in this case, let's say that our column was pretty crooked. What you would see instead, this is the silica line, But as those two bands traveled through, instead of seeing them just parallel to one another and again perfectly perpendicular to your column, what you'd see is something that looks more like this. You have the yellow band kind of slanted. Then you'd also have the green band slanted if you had loaded in your compound in this slanted manner. And the issue with this is that at a certain time point, say if you're trying to collect the fraction that falls between here and here, you're not really getting the pure yellow compound or the pure green compound. Instead, you're getting some mixture of the two, which shows that this isn't a very efficient purification. So what you'll want to do next time is be very careful in the initial stages, because a lot of the work with column chromatography is making sure that you prep it just right, and the rest is just waiting and letting your solvent run through. So let's review what we learned today. We learned how to pack a column using cotton, sand, and silica gel, and we also learned how to separate compounds using column chromatography based on their polarities.